If you're building a .NET MAUI application, you'll need to know how to create an interactive UI. So that being said, let's build an interactive UI in our .NET MAUI Bugporter application. So where we are right now with Bugporter, we have our Azure Functions backend API that exposes an endpoint where clients can report bugs to our GitHub repository. And last time we scaffolded out our .NET MAUI application and introduced some MVVM essentials, but currently our .NET MAUI app doesn't have really a UI at all. There is no form where users can report bugs to our backend API. So that being said, let's build out our UI, a form for users to report bugs. We'll do our best to make it look good and be simple to use so that our users are satisfied. And next time, we'll connect this form to our backend API so that we can report bugs to our backend and get those pushed to our GitHub repository. So building out our .NET MAUI UI, it's going to be more than just writing some XAML. Not only are we going to write XAML to represent our UI, but we also need to bind our UI to our view model so that we can have the data on our UI pass throughout the rest of our application. And we also want to stub a .NET MAUI command so that when the user presses the submit button on the UI to report a bug, we can pass that bug to our backend API. But again, just stubbing that command, not going to actually be interacting with our backend API until next time. Now, before diving into binding or commands, we need to actually create our UI. So let's take on this first task of creating our report bug UI. This part will probably be the most satisfying. Last time, we scaffolded out this report bug view that binds to a report bug view model. And the whole point of this was just to demonstrate some MVVM principles, such as binding. Now, as we can see, this view and view model, they live in this pages directory. So the whole point of the pages directory is to represent full pages in our application. So ideally, I only want pages inside of here. I don't want any complex business logic or any kind of service calls, etc. I just want pages represented in this pages directory. So everything related to this report bug form that we want to build is going to go in another directory. So let's add a new folder here, and we're going to call this features. So you guessed it, we're following vertical slice architecture here, feature sliced architecture, whatever you want to call it. I have a whole series on that on my channel if you want to learn more about it. But really the main goal here is we want our application to be cohesive. So things that are related to each other are going to be grouped together in our folder structure. And we'll see that in action when we create this report bug form. So following that principle of vertical sliced architecture, we're going to add another folder in our features folder. And this is going to be called report bug. So all the business logic, all the service calls related to reporting a bug are going to live within this module. And starting off, we want to create our report bug form UI. So in this report bug feature slice, let's add a new item and let's select .NET MAUI over here. So are we creating a content page or a content view? So when we created the report bug view in the pages directory, we selected content page. And that makes sense in that context because the report bug view in the pages directory represents a full page. But for this form UI that we're going to create, we want to use a content view. And the reason for that is that our report bug view page is going to use our report bug form content view. So in reality, content views are probably more equivalent to user controls in WPF, probably more equivalent than a content page is. So this content view, we'll call it the report bug form view. So getting started with the report bug form UI, we're going to have a vertical stack layout in here. So all the elements that we put inside of this stack layout are going to be stacked on top of each other vertically. So we're going to begin in here with another vertical stack layout. And inside of this vertical stack layout, we're going to have everything related to our first input field. So that's going to be where we get the bug summary from the user. So we're going to begin with a label inside of this vertical stack layout, and we'll have a text of summary on this label. And of course, we want the user to actually put in the summary. So underneath this label, we'll have an input box, an entry in .NET MAUI, so the user can go ahead and type in their bug summary. So underneath this summary field, we're going to have another field contained within a vertical stack layout. And inside this next vertical stack layout, we want the bug description. So we're going to have a label for description, and the description might be a little bit long. So we're going to have an editor here instead of an entry. And the nice thing about editor is that it can take up multiple lines, and we can make it large or have a bigger height by default. by defining a height request. So by default, it'll take up a height of 100, have multiple lines by default. And finally, once the user puts in a summary and description for their bug, they can submit it by clicking a button at the very bottom of our form that'll just have a label of report bug. So now that we have the skeleton of our report bug form, of course, we're going to have to make some styling enhancements. Not sure how it's going to look. Let's actually see it when our application boots up. So when we boot our application, we show the report bug page. So all we need to do is use this report bug form view component in our report bug view page. So in our report bug view page, let's begin by getting rid of this boilerplate from last time that we used to show off binding. And to reference our report bug form view, which lives in another namespace in our feature slice, we could first define a namespace in our XAML. So we can do an XMLNS, and we'll give this namespace a key of report bug, and we'll just point to our report bug feature slice. And IntelliSense should work here to pick up this namespace. And next up, in our XAML, we can simply reference this report bug namespace and find our report bug form view. And now, when we boot our application, hooray, we see our beautiful report bug form. Look how good that looks. All right, in order to make this report bug form look better, the biggest thing we need is some spacing. So let's add some margin. First off, let's add a little bit of margin between our labels and our inputs, maybe a top margin of 2. And we'll do the same thing for our description field as well. And then we could also use some margin between each of these inputs, groups of inputs with the label and entry. So let's add some top margin of 10 on the description field just to get some spacing between these two fields. And we could also use some top margin on our button as well. Let's go for 25. And we also saw that this report bug button took up the entire width of our layout, which didn't look great. So let's define horizontal options of start so that we can push this button all the way to the left and it's not obnoxiously big. Some other minor enhancements, I would like these labels to be bold just to stand out. So let's define font attributes of bold on each of our input labels. That should be all the styling that we want on our report bug form. But moving up to the page layer, I would like to add some more styling and define the layout of our page. So starting off on our page, let's add a padding of 25 so that our entire form isn't pushed up against the edges of our window. We should also wrap our UI in a scroll view, so we get a scroll bar whenever our content is exceeding the height of the window. I also want to add a width constraint to our page because otherwise, say our window was like 3,000 pixels wide, then our form would stretch to take up all of that space and it would make our form inputs look kind of weird because they don't need to be that wide. So let's set a constraint of 1,000 width, and we're defining maximum width. So if our window is less than 1,000 width, then our page will be able to shrink to whatever our window width is. So it won't be locked in at 1,000. I'm also not a fan of the default styling on this .NET MAUI navbar, and I'm not ready to style it just yet. We'll get to that later. So for now, in our app shell, we can set the shell navbar is visible to false and simply hide it. And with the navbar hidden, I feel more comfortable adding a title to our report bug page. So above our form, we'll have a label with a font size of large, make it bigger than the rest of our form and stand out since it's a header. And we're gonna have a text of report a bug because that's the main goal of the form. And making this look good, let's add some spacing. So we'll have some top margin of 25 between the form view and our label. All right, satisfied with how this looks, we could probably play around with the margins and perfect those. And the overall theme, I feel it could be better. We should probably customize that to fit our application in the future. But for now, our UI looks solid and is pretty simple to use. So with our XAML UI functional for the report bug form, let's close out this story for creating the report bug UI. And let's commit these changes referencing our story. And next up, let's bind this report bug UI that we just created to a view model that we're going to create as well. And this will allow us to get the data that the user put into the UI and pass that along throughout the rest of our application. So we're going to add a view model for the report bug form view. So where should this go in our folder structure? Of course, it should live right next to the report bug form view, since that is what's going to be binding to it. So let's add a new class in this folder, and this will be called the report bug form view model. Since this is a view model, we're going to inherit from our view model base that we have in our shared layer that implements iNotifyPropertyChanged. And what is this view model going to define? So relating to our UI, we need a property to hold the summary for the bug that the user puts into the UI. We'll need another property to hold the bug description, and we'll need another property for a command that will execute when the user clicks the report bug button. So on our view model, let's use our handy prop change snippet to create a property that raises property changed for our .NET MAUI UI. Relating to our UI, this property is going to be for the bug summary. So we'll name it, of course, summary. Let's have another prop change. And by the way, I'll leave a link to the prop change snippet download in the description. But this property will be for the bug description. And lastly, we need a command that will execute when the user clicks the report bug submit button. So this will be a property for an I command, and we'll call this the report bug command. And we'll get into implementing this command in a bit. Now we need to tell our report bug form view to bind to the properties on our view model. So for instance, this entry for the bug summary is going to bind to our summary property. So the text that the user puts into this entry component will bind to our summary property on our view model. And same exact thing for this editor. For the bug description, the text is going to bind to the description property. And lastly, for the report bug submit button, whenever the user clicks this button, it's going to execute our command to report the bug. And that is represented by our report bug command on our view model. So we're going to bind to that command. So that's it, right? So since the report bug form view and the report bug form view model, they live next to each other in the same folder, they have the same prefix of report bug form, that means they're just going to magically know how to bind to each other, right? Not quite. So ultimately, if we want this report bug form view to bind to a report bug form view model, we need to set the binding context of the report bug form view to an instance of a report bug form view model. So where can we do this? Let's move higher up. Let's move up to the report bug view. So this is our page that renders the report bug form view. So on this report bug form view that our page uses, we can set the binding context. And again, we ultimately want this report bug form view to have a binding context of a report bug form view model. So where can we get that report bug form view model from inside this page? Well, we can get it from the report bug view model that this page binds to. So this is what we used last time to demonstrate binding. Let's get rid of this boilerplate from last time. On this report bug view model, we can have a property for a report bug form view model instance. So let's expose this property. We can just have a getter because we're going to set this just once when this view model initializes. Let's import our feature slice namespace, and let's get this view model injected through the constructor. So now we have a report bug form view model instance on our report bug view model, and our report bug view binds to this report bug view model, which means we can pass along this report bug form view model as the binding context to the report bug form view. So let's set that binding. So the binding context is going to be a binding to the report bug form view model, which is on our view model. And now since a report bug form view model instance is the binding context to our report bug form view, then all of our bindings are going to be able to link up to our view model. So last piece of the puzzle, we need to get this report bug form view model injected through this constructor. This is all configured in dependency injection. So if we move up to our MAUI program, we simply need to register the report bug form view model in dependency injection. And by registering this, it'll allow us to resolve this view model when we instantiate the report bug view model for our page. And now to prove our bindings work, I have a breakpoint on our summary property. So whenever I type into the summary field on our form, we hit our breakpoint and our summary property gets set with the value that we passed in to our entry box. So our binding mission is complete. Our report bug UI is binding to our new view model so we can close out this story and commit our changes linking to our story ID, which means we can bring in our last story of stubbing a command to report a bug to our backend API. So this is the command that's going to execute whenever the user clicks the report bug submit button. Let's move this to in progress and get started. Now, reporting a bug is going to take some time. We have to make a network request to our backend API and then wait for a response back to our client. And since this is going to take some time, we want to execute this asynchronously. And we want this to execute asynchronously so that we're not blocking the UI and not allowing the user to do anything while we're waiting for a response. So that being said, we need to implement an async command so that we can execute the logic to report a bug asynchronously. So in our shared folder of our application, let's add another folder for commands. And this is all going to go in the shared folder because it's not related to the business logic or domain of our application. Really, anything we define in this shared layer could be applied to any application. So what we're defining here is going to be a base command to execute something asynchronously. So we're going to call this async command base. And any command will be able to inherit from this command to execute something asynchronously. And I really don't want to go through all the intricacies of async commands here. I have other videos on my channel where I go through async commands more in depth, and I'll link the source code in the description if you want to read through our async command implementation more in depth. But let me just paste in an async command implementation. And really the main pieces here are we have an is executing property, and we can only execute an async command if we're not already executing. So just make sure that users can't spam the button for an asynchronous request. And the meat of the command's execution, we set is executing the true. We do something asynchronously. So this is the async operation that is implemented by the class that inherits from our async command base. Ideally, the async operation will handle exceptions, but if an exception slips through, we catch it and pass it along to an optional onException handler that can be passed through the constructor. And finally, we set is executing to false. So now that we have this async command infrastructure, we can stub out our command to report the user's bug to our backend Azure Functions API. So where is this command going to live to report a bug? You guessed it. It's going to live in the report bug feature slice with the rest of the report bug logic. So in this feature slice, we'll add a class for the report bug command. And obviously, this is going to inherit from async command base. Since we want to hit our backend API asynchronously, let's import this and implement this abstract class where all we need to do is provide the implementation for whatever we want to execute asynchronously. And since we're just stubbing this command, we're going to do nothing for now. But next time, we want to pass the bug that the user reported to our backend API. So where do we get the summary and description for the bug that the user wants to report? Well, we get it from the report bug form view model that we implemented previously. So if we want to get that summary and description in our command, we need to get that view model passed through our constructor so that we can reference it when we execute our command. So let's get a field in here for our view model, and we'll get it passed through the constructor. And with our command stubbed out in our view model, we can finally define our report bug command. So in the constructor, we'll set the report bug command property to be a new instance of the report bug command that we just created. And we need to pass in a report bug form view model instance to this command, which is simply represented by this. So we want to pass in this instance of our view model. So now when we press this report bug button on our UI, we execute our report bug command, and we can take a look at our view model instance on this command. So look at this field, and we can see our bug summary and description, which we'll use next time to pass along to our backend API. So just like that, we've stubbed out a command to report a bug to our backend API. So we'll implement that more in depth next time and actually hit our backend API. But we can close out this story. Since it's stubbed out, we can complete our sprint. I suppose we should have committed our changes first, but let's commit these changes referencing our story. So just to summarize, we created our report bug form UI via XAML. Then we binded that UI to a view model so that we could get data from the UI and pass it throughout the rest of our application. And finally, we stubbed out an asynchronous command so that whenever the user clicks the report bug button on the report bug form, we'll eventually pass that bug along to our backend API, So overall, apply these concepts to build your own interactive UI for a .NET MAUI application.